Hello everyone, welcome to my YouTube channel Chemistry Quest. This is the third lecture on biomolecules chapter. In this video, we will be discussing the D and L configuration in stereochemistry. So please remember that it is the capital D and capital L. Small d and small l have different meanings in stereochemistry that we will discuss in some other video. Now, for getting the D and L configuration of carbohydrates, especially, we take the reference molecule as glyceraldehyde. So, this structure is glyceraldehyde and it is compared with glucose. Okay, so basically, vertical line and it has got intersection of horizontal line. It is the Fischer projection. These vertical lines and horizontal lines intersection point represents the carbon atom. So Fischer projection is a two-dimensional representation of an organic molecule. So when we have to assign D or L configuration to any compound, we have to take a reference molecule. For carbohydrates, the reference molecule is glyceraldehyde. So this is the glyceraldehyde molecule. Here CHO group is present. Here it is the chiral center and here CH2OH is present. So this has one chiral center. So glyceraldehyde has one chiral center, and if you notice, the OH group is present on the right side. So this is the catch. So if OH is present on the right side of the molecule of glyceraldehyde, it is known as capital D glyceraldehyde. And when the same glyceraldehyde is compared with the glucose, we have to take the lowest asymmetric carbon, that is this carbon. So in this carbon also OH is on the right side. That is why it is capital D glucose. So let me explain what I have explained on the reference molecule. So the exact spatial arrangement of different OH groups. This is OH group, this is OH group, this is OH group. It was given by Fischer. Fischer was a scientist. He studied many properties and he finally gave the structure of glucose as this molecule. This is the CHO group. This is first carbon. Second, this is third, this is fourth, this is fifth, and this is sixth. Glucose, you know that is C6H12O6 molecule. Now, what is the meaning of D and L configuration? We will revise it once again. So, the letters D or L before the name of any compound indicate the relative configuration of a particular stereoisomer of a compound with respect to configuration of some other compound, configuration of which is known. In the case of carbohydrates, this refers to their relation with a particular isomer of glyceraldehyde. So, if plus isomer of glyceraldehyde has D configuration, it means that when its structural formula is written on paper following specific conventions, the OH group lies on the right hand side in the structure. That is why it is known as D and it is given plus glyceraldehyde. All those compounds which can be chemically correlated to D plus isomer of glyceraldehyde are said to have D configuration. Right? Now next we will study about the asymmetric carbon. So as I have already explained that the carbon atom which has four different groups attached to it, that is A, B, C, D, it is known as the chiral center or the asymmetric carbon. So please remember that for assigning the configuration of monosaccharides, it is the lowest asymmetric carbon which is compared. In this glyceraldehyde also this is the lowest asymmetric carbon, and in glucose also this is the lowest asymmetric carbon. So we have to remember that while assigning the configuration, we have to remember that we have to take always the lowest asymmetric carbon for comparison, right? Now, as in plus glucose, OH on the left lowest asymmetric carbon is on the right side, which is comparable to plus sign of glyceraldehyde. So plus glucose is assigned D plus glucose and D plus glyceraldehyde. So we have to remember one more thing is that there are many asymmetric centers in glucose, but other asymmetric carbon atoms of glucose are not considered for this comparison. As you can see in this glucose molecule, this is the chiral center, This is the chiral center, this is the chiral center, and this is the chiral center. Total 4 chiral centers are there in B plus glucose. So the lowest asymmetric carbon is this. It is compared with glyceraldehyde OH group, whether it is present on the right side or on the left side. And one more thing while writing the Fischer projection is that the more oxidizable carbon has to be written in the top. That is CHO, CHO. This is given as a number 1 for numbering the glucose molecule or any other carbon chain. So if you like the video, please hit the like button, share with your friends, and don't forget to hit the notification bell for upcoming videos. Thank you and have a nice day.